A and AS level mathematics. Lesson 4, some more algebra. And we're going to be looking at solving linear inequalities and solving quadratic inequalities. So let's look at solving these linear inequalities. We'll deal with this the same as we do with an equation. We'll add 6 to both sides, and then we'll divide both sides by 4. That shows dividing by 4, but we should always simplify where possible, so that's 2.5. Now the process would be exactly the same if it was less than or equals to. There'd be no difference in the way that we do it. Let's look at this one. I'm going to subtract 7 from both sides. So I'm left with minus 2x on this side. If I subtract 7 from that side I get 5. Now this is the only difference between working with inequalities and equalities. I'm going to divide both sides by minus 2. So that becomes plus x, and this becomes minus 2.5. And when you multiply or divide by any negative number, the inequality turns round. That's the only thing you've got to remember on top of dealing with equations and inequalities. If you multiply or divide an inequality by any negative number, the inequality turns round. Again, that won't make any difference if it's got an equals part to it. Now this one has got 3 parts to it. It's got minus 6 is less than 2x plus 1, which is less than 9. And to do with this, you have to deal with all 3 parts. So the first thing I'm going to do is subtract 1 from the middle part. So therefore I have to subtract 1 from each of the other parts. Now I'm going to divide the middle part by 2. So I'm going to divide each of the other parts by 2. So you deal with the middle part, and whatever you do to that, you do to the ends. Now let's have a look at solving quadratic inequalities. Find the range of values of x for which. Let's have a look at this with an equals sign to start with. And let's in fact look at it as a graph. Let's multiply this out. So we get x squared minus 1x minus 5x plus 5. So we're looking at the graph of y equals x squared minus 6x plus 5. Looking here, if we put this equal to 0, we'll be finding where it cuts the x-axis. So it's a parabola, and it cuts the x-axis at plus 1 and plus 5. Therefore the y-axis is over here somewhere. We can quickly see where it cuts the y-axis, so let's put that in as well. Now, what in fact we're doing is at these 2 points we're saying that the equation equals 0. But we want to know when the equation is less than 0. So in other words, any x value between there and there will give you a result below the x-axis, therefore less than 0. So the answer to this is in fact any x value between 1 and 5. And we write that like this. So there is the answer to that quadratic inequality. Looking at the graph, appreciating what's going on, I hope you understand it. Now if in fact there was or equals to, then that would make no difference to my thinking at all. So let's have a look at this one. Find the range of values of x for which. Now again, let's look at the graph to make sure we appreciate what's going on. So if we multiplied this out, we get x squared plus 1x minus 3x minus 3, which is x squared minus 2x minus 3 equals y. Therefore the graph is a parabola. It cuts through the x-axis when this equals 0, which means x equals minus 1 and x equals plus 3. So this must be minus 1 and this must be plus 3. Therefore the y-axis is about there. And in fact we can also say where it cuts the y-axis at minus 3. Okay, so between these 2 points, this is less than 0. Therefore any value of x less than minus 1, or any value of x greater than plus 3, will give me an answer greater than 0. So in fact my answer is going to be both those things. Any x value less than minus 1 and any x value greater than 3. Again, doesn't make any difference whether we include the and equal to part. Making this equation, which it is when we multiply it out, greater than 0. Now sometimes we might have to manipulate the quadratic inequality before we start, because we want to work with greater than 0 or less than 0. So the first thing I'm going to do here is I'm going to subtract 4x from both sides and subtract 12 from both sides. Now I'm going to factorise it. I want two values that multiply together to become minus 12 and add together to become minus 4. So if I do minus 6 and plus 2, I think you'll find that'll do the business. So in other words, when x equals 6 and when x equals minus 2, then it comes to exactly 0. So there's our parabola. Therefore it cuts the x-axis at minus 2 and 6. The y-axis is somewhere over there. But we want this to be greater than 0. So greater than 0 will be any x value, because this is now greater than 0, less than minus 2. So it's x less than minus 2, and any x value greater than 6 will produce an answer of greater than 0.